Okay, so that leads us to what we were talking about the last time that we met, when we were looking at inverse sine and inverse cosine, and we're going to be looking at inverse tangent today. So we'll start off with the inverse tan of negative square root of 3. Now, we had said that when we were looking at inverse tangents, or sorry, inverse sine and cosine, that there were 3 steps that we sort of needed to follow: determining what quadrant we were going to be in, determining the specific point on the unit circle within that quadrant, and then be sure we name the angle correctly. Well, we're still going to sort of follow these same 3 things. All right, determining what quadrant I'm in. Well, I know that tangent is going to be restricted to the first and fourth quadrants. And because my tangent is negative, I know that I'm going to be down here in quadrant 4. Does that make sense? Okay. So that's step 1. We know we're in quadrant 4. Now I need to determine exactly what point or angle that I'm on my unit circle. Well, unlike sine and cosine, I can't just look at these points here and automatically figure out a tangent. So I could do sine over cosine, or y over x, that divided by that, that divided by that, that divided by that, and see which one equals negative square root of 3. But I've got my exact value chart that's going to allow me to save a little time here. I know that the tangent of pi over 3 is the square root of 3. So this pi over 3 is a reference angle. So I have, I'm going to sketch this out here. I've got a reference angle of pi over 3. Does that make sense? Okay. Now, my second step here says determining the point on the unit circle. Well, I'm not necessarily looking at the coordinates of this point, but more so the measure of that angle. That angle is in side this right triangle here with a measure of pi over 3, but I want to know the measure of, or the name of this angle, if I'm looking at the restrictions from negative pi over 2 to pi over 2. So that's this third step here, is to be sure I name that angle correctly. Okay. Let me go back to this. So this says pi over 3. That would be equivalent to the 5 pi over 3. I'm not going to name this angle pi over 3 because obviously it's not an acute angle. It's not an acute angle. And I'm not even going to name it 5 pi over 3 because 5 pi over 3 would be going all the way around here, and I can't go past this second quadrant when I'm looking at my graph. I have to name this angle as negative pi over 3. Does that make sense? Okay. We figured out what quadrant we're going to be in, and we figured out exactly what point on that quadrant, or the angle. And then we had to be sure that we named it correctly. If I'm down here in quadrant 4, then I have to have a negative angle name for my tangent, or inverse tangent, I should say. Okay, so let's look at our second problem here. Okay, guys, hang on a second. I've got to find me a pen that will work. There we go. The inverse tan of -1. Okay, so again, I know that tangent is negative, so I'm down here in quadrant 4. Hopefully by now you know what angle that's associated with. Can anybody figure out that off the top of their head without having to look at your chart? What reference angle is that associated with? You may know. Is it what? Not pi. Cosine of pi is -1. I'm looking at tangent here. Pi over 4. It's this angle right here is pi over 4. And again, you can look at this unit circle, not your unit circle. Let's go over here. I know that when my chart here, tangent of 1 is pi over 4. So it's associated with that angle, but this angle is actually going to be negative pi over 4. And I think it's kind of important here that I stop for a second and talk a little bit about that value of 1. Remember that if I'm looking at tangent of theta, I could look at it as sine theta over cosine theta. And if I'm on the unit circle, that's just going to be y over x. Well, if y and x are the same value, right, if x and y are the same number, right, like 3 over 3, or in this case, square root of 2 over 2 and square root of 2 over 2, anything divided by itself is 1. And what that means geometrically for a right triangle is that I have these two sides here that are the legs of the triangle are the same. They're equal. So I have an isosceles right triangle. And I know that each of these angles being 45 degrees, then these sides are going to be equal. If the angles are equal, the sides are going to be equal. Does that make sense? You remember that from geometry? Okay. One more quick problem here. And this is just to be sure that you know how to do this on the calculator. So if y'all will use your calculators to figure this out. And we've done these problems before, so that's nothing new. I am in radians. So be sure your calculator is in radians as well. Let's see. Ahmed here. Okay, you should get approximately -1.54. Is that what y'all got? All right. Be careful with the directions on that. I think the problems in my math lab may ask you to take that out to more decimal places.